Okay, we are back, and now we're switching to English again for our last presentation of today, which is with the company Freemelt. And with us today, we have Daniel Gidlund, CEO of the company. Daniel, the stage is yours.
Thank you. Yes, Freemelt, we are a Gothenburg-based company. Actually, the founders were all coming from another successful Gothenburg-based company called Arcam. So, company-wise, we were founded 2017. And what we do, we work with advanced 3D printers for metal. Technology-wise, it's called electron beam powder bed fusion. So where we focus, of course, in metal applications, we try to focus, of course, where additive manufacturing adds value as well. Additive manufacturing, or 3D printing, as it's also called, has been available for pretty much 30 years. Main focus still, after the 30 years, has been in prototype printing. There is still huge opportunities when it comes to serial production for industrial kind of context. Our kind of technology is more in high demanding applications, more complex kind of applications where high demand on material properties, like for instance in defense, like in energy, and also in medtech. So some sort of connection to a lot of the other speakers today, it's in medtech as well. Medtech is actually the most mature, highest adoption rate of serial production for additive manufacturing. So there are a lot of machines around the world there. Our kind of technology, as I said, it's been 3D printing there for 30 years. Prototype printing been the key focus. We have a totally new kind of concept of 3D printing. Most of the 3D printers, you work at the machine, which means that you block a lot of time for production. If you have a factory, what do you want? You want to have short cycle times, so real high availability to get high productivity, to get down the cost per printed part. And we have a modular system, which is totally unique. So all the preparations for the build is done somewhere else, not at the machine. And then when the build is done in the machine, you swap that build model to another one that you have prepared. So really to shorten down the cycle times in the printing process. We have, as you can see here as well, 3 different kind of machine models. The first one was launched 2019, which is for research. So we sell typically to the academia, universities, research institutes. We have sold 27 of them, and then we have sold 3 of the industrial printers. So this is a technology that is working, customers are using it. Where we are as a company, we are just now going to a commercial phase. The majority of the academia that we've been selling for, since 2019 is also critical for us, because still additive manufacturing, it's roughly, I would say, 1% of all the metals produced, or metal parts produced, is done with 3D printing. So the opportunity is still very, it's huge. So it requires a lot of education. And this is why we go through universities. So they also first help industrial clients to develop new processes, new applications, and really to make the value out, to get the total value out with 3D printing. Last year, we had a commercial kind of breakthrough in industry. We signed a deal with Saab during the year, so Saab Dynamics in defense. So we worked together with Saab to develop applications in copper. We also, a major breakthrough, I would say, from an industrial side, was end of last year in October, November, where we signed 2 agreements. So one with one of the big global implant OEMs, and then the second one is with one of the other implant OEMs as well, which already using 3D printing. If you look into us and the team, as I mentioned, the 6 founders were all coming from Arcam, pretty much behind the EPBF technology, so extensive technical knowledge. but we also have a very strong and diverse board. The chairman is Carl Palmstierna, was in the senior global leadership of Goldman Sachs in the 80s and 90s. We have Johannes Schleifenbaum, which is the professor in Aachen, which is really a center of excellence for additive manufacturing. If you look at myself, I have a background commercially from Sandvik, 15 years in mining equipment in the aftermarket, and we're trying to get in more commercial type of and more strategic leadership into the company now as well when we're expanding our business. From an ownership point of view, Industrifonden is the single biggest owner. We have Bengt Hylander, also connected to life science. That is also one of the big shareholders. And then we have Coeli as well. We have roughly approximately 5,000 shareholders. We're listed at Nasdaq First North. So this is additive manufacturing. So again, instead of like the traditional technology where you have a big piece of steel and you cut it down to the final product, here you put a layer by layer of powder. And the powder is like the size of the hair. So it's very small powder. What you see on the upper right side here as well, it's how fast the electron beam goes when it's melting. So it's not laser. This is an electron beam moving 4 kilometers per second. And then you put out a new layer and you melt it, put out a new layer, and you build this heat exchanger that you can see here. And additive manufacturing, you have no design limitations. So you can really design the product and manufacture product in really unique designs, in functional design, instead of like a typical product where you need to maybe weld it together in different kind of parts. There you can build it in one piece, which means it gets stronger, totally different kind of functionality. You can make it lighter with the kind of material that you use as well. If you talk about transformations, that typically happen when you have crisis. And as I said, 30 years now, and it hasn't really started to take over from traditional manufacturing. What we have now with the geopolitical situation, we see a big change in the last 2 years, mainly from defense, semiconductor, energy, and medtech, not because of geopolitical. So now it's really starting to be a big pull from especially US, but also in Europe as well, to try this technology for developing new type of applications. So fusion energy, for instance, if you take energy, is something that has really now started to being much more, let's say, of interest as well. And then, of course, defense, as I mentioned. If we zoom in then on these three key focus industrial segments that we're working with, I mean, defense, it's a huge business. And yeah, as I just said, I mean, it's even... at least during my lifetime, never been as much, let's say, investment focus, and also in new kind of innovations. If you take hypersonics, for instance, new type of products that is really now getting a lot of attention to, and then you really need to get them quick. So you need to have a fast development process as well. And this is where additive manufacturing is really crucial. You can see a few of the clients that we have currently, both in Sweden, in Europe, and in the US as well. It's important to mention in the US, then it's really crucial to go through the universities or the research institutes that qualify the technology for the industry. So every time we sell to a US research institute, there is an industrial client behind there as well. Energy, as I mentioned here, it's mainly focused on fusion. We have a really long and great collaboration with United Kingdom Atomic Energy Authority, so UKAEA, which we have worked together with 2 years. You have ITER, I think it's the largest R&D project in the world, that also focus on fusion energy. In the US, also a lot here. And of course, a lot of the universities and institutes also focus a lot on that partner as well. And then last but not least, we have medtech. As I said, the highest adoption rate of using additive manufacturing for serial production today is in medtech. So if you go to the big medtech companies like Stryker and so forth, I mean, they already have hundreds of 3D printers producing 24/7. Just to give you 3 examples from those different sectors. If I start with the first one, so these are then clients that we are in different kind of stages discussing with. So if we take the first one here, it's that's about the energy. So here, for instance, if that would materialize, we're talking almost 80 machines. That would be, this is for fusion energy when they need to develop or manufacturing 1.5 million tiles. So in those fusion reactors, they put in small tiles in tungsten, which can resist the heat and the radiation that is in there. The middle one, a different type of energy application, but also aerospace. It's a collaboration. We have 4 parties in this. Again, if we would swap from the traditional manufacturing that they're doing there, it would drive more than 1,000 printers to keep up with the demand. And then last, it's medtech. So one of the implant OEMs that we have an agreement with, if that would also materialize and really go well, it just one application would drive more than 100 machines. So when it comes to industry, and this is why it's so important for us to get into the industry, then we're talking bigger volumes. Now, so far with the machines that we've been selling, then it's more individual sales of machines. The biggest change that we saw last year compared to the years before, so if you go back to 2023, we had 3 paid customer projects. So when a customer comes to us, can you develop a material process for this application? So it's an industrial customer that sees the value and would like to try the technology. Last year, we had 23. So we saw a huge swing. So as I said before, it's a lot of to educate the market, but the market now start to realize this. And as I said, especially, actually 75% of all these 23 is from energy and defense. So huge spike there last year. I don't say that all of these will materialize in machine orders, not be successful for the application, but the one on the top that you see, the 2 implant OEMs, they now start to qualify our products. So they have invested in machines, the industrial machines from us. If we succeed there, then of course, I mean, we expect to get volume orders of machines. Our business so far has been very transactional because selling to universities, this research machine that you saw on the first slide, which is like 4 million per machine sale, very small aftermarket business, unfortunately, for the universities, has been around pretty flattish, I would say. So we haven't, the financial guidance that we just announced, it will end up around 20 million SEK for 2024. But moving forward, if we start to see materializing of the 23 studies, and we can get in more studies every week, of course, then volume demand of machines and aftermarket, because an industrial client will like the machine to run 24/7 and generate a lot of aftermarket as well. So, I mean, company-wise, we started 2017. We have invested in the technology since then. We have the industrial machine ready. We have the research machine there as well. So I think the value that we have gained into this company now is higher than ever. We also now start to add more commercial people to grow the business. We have a team in US, in Europe, which is the focus at this moment. Thank you very much.
Okay, thank you very much for the presentation. Do we have any questions from the audience to start with? Yes, over here.
So I have a question around if you have a service business connected to your offering today, is that the aftermarket sales, or if not, what are your thoughts around that kind of dynamic?
Yes. Unfortunately, the research institutes and universities, they get the budget to purchase a machine. So it's very small. My background is aftermarket. I really know the value both for the customer and for us as well. So of course, that's one part that we try to establish now for the industrial clients, because they demand that we can serve the machine. They even demand that we have a preventive maintenance as well to avoid the downtime as well. So at the moment, it's really a transactional service business, but definitely we try to set that up.
Thank you for the presentation. I'm Bo. I wonder, have you thought about the way that Arcam made a lot more after sales? They bought an American company who made metal powder. Is that some route you are thinking about going?
It's a very good question. We actually, I can be a bit harsh because I'm coming from outside industry. So we try to do it a bit different. Personally, I don't think it really have been any successful, a few successful. EOS, I think, is a success in this industry. But it's really a closed ecosystem, mainly in the industry. So you need to buy the machine, the software, the powder from one supplier. And we try to think different. So we have actually given the customers the opportunity. They can buy the machine, but they also, if they would like to buy powder from someone else, because they have a mixed fleet of machines, for instance, we give them the opportunity. So in our offering, we can offer powder, but we collaborate with, for instance, Sandvik is one of our partners. And then we ask Sandvik then to have that discussion and even then make that revenue as well. So to answer your question, no, we have excluded that from our offering because we don't really see we add enough value there.
So you work better in partnerships with those
Exactly.
customers?
Yes.
Okay. Is that going for Höganäs as well?
So far, we only have an agreement with Sandvik, but of course, I mean, we're looking to other partners as well.
Thank you.
No worries.
Any other questions from the audience? No.
Thanks.
Sorry.
Great presentation. Just curious, can you elaborate a little bit on the competition you're facing?
That's also a good question. I mean, actually, our competitors that we try to focus on is the traditional technology like CNC machining. But unfortunately, we end up focusing a lot on laser powder bed fusion, so laser machines, because they have already managed to get the end user to be convinced that additive manufacturing is adding value. And our benefit to laser is speed, so we can produce much faster. It's also hot processes, so we can also produce parts that have a much higher material property and quality. So, but competition-wise, there is, GE that acquired Arcam, for instance, that's a competitor having similar technology like us, and we have 8 others as well, Chinese and some Germans at the moment. But we are number 2 after GE at this moment.
Interesting. So I had a question, like you mentioned some projects here, some you exemplified in the presentation, and like you secured several new projects during 2024. So can you just share with us which one of the projects that excites you like the most and why?
It's a difficult question. I would bring up Saab. I think Saab Dynamics is one of the interesting one. Why? Because we have 3 materials. We have tungsten and we have titanium and then copper. And with Saab, it's actually with copper, ultra pure copper. And so I would bring up Saab. The other 2 is the 2 implant OEMs where we managed to get from feasibility study into proof of concept. And as I said, I mean, these 2, they are experienced in additive manufacturing, which means they raise high expectations and demands, and that we managed to succeed in that evaluation makes me really proud as well.
I see. And when we looked at like your numbers here before, we noticed like no particular growth in 2024. So was this expected, or how should investors view this?
I think, of course, I mean, we always try to improve also sales because we educate the market. But so far, I mean, we just put the industrial machine out in July last year. So during last year, I think sales was sort of expected. more important is, and that's also why we start to share the number of projects, which we went from 3 to 23. So on that note, I think that's more important for investors to have an eye on, because that hopefully will materialize in more volume orders later on.
And like given that increase in number of products from 3 to 23, from 23 to 24, how are you expecting 2025 to like develop with this in mind?
I think at least, I mean, number of products definitely increase, or continue to increase in a nice way, because again, market gets more and more aware of Freemelt and the technology, and as I said, now we even start to feel a pull from defense and energy. I think on that side it should continue. And of course, I expect that we start to see some sort of materializing of the projects from last year in machine opportunities this year as well.
Yeah, that's exciting. And like lastly, I think many investors may be curious, like how you plan to scale up the business now when you're experiencing a lot more like project request and demand from customers and demand for your printers to grow. So how like capital heavy or capital light is your business model?
I think the research business is very efficient. There we have a very short order to deliver process as well. We have a good margin, 65% margin on that one. When it comes to the industrial side, that's more long lead items, first of all, so it takes a bit more time. We're not 100% efficient when it comes to the bill of material, so that drives more capital initially now as well. And of course, we are entering it. For us, we're trying to get into a market, and we need to invest a bit in the market as well. But I think we have outsourced a lot of subsystems to partners that build subsystems for us. We can shorten the need of having capital tied up at least. And then also on the sales side, I think we have a good structure. We have 2 regions. We try to be quite self-sufficient there to sell and also to service the customers out there as well.
If not, then we thank you very much for joining us today.
Thank you.
Okay, so that concludes all the presentations today. Thank you everybody for coming here today, and thanks to everyone watching in online. See you next time.